Unfortunately, the bell rang before we could finish these notes for 5-5. We have examples 4 and 5 left, so this will be 5-5 part 2. And so the first thing that you want to do, though, is make sure that you can use a normal approximation to find these particular answers. So n here is how many people that you're going to be talking about, or how many trials, remember, and so that's 200 for this problem. And your probability of success is, well, not very good. 29% are confident that there'll be passenger trips to the moon in their lifetime. And if 29% are sure that there will be, then 71% will not. And so we have to check. Remember, NP and NQ have to be greater than or equal to 5. And if you remember, the reason is that the further that gets out, yeah, it's got to be on here somewhere. There it is. The further NP gets out, the more normally distributed that it is. And we'll be using this picture again, so I might as well get rid of that. And so let's see if we can figure this out. So NP is probably the one we're going to do first, because it is the smaller of the two, and so we might as well know if that's bigger than or equal to 5. And NP here is 58, and so we're good. If we want to know, we could do NQ, and I believe that ends up being the other 142. And you notice that adds to, nobody said it yesterday, but that adds to 200, of course, because of the percentages. So it works. Well, let's figure out the mean then. And the standard deviation. Remember, the mean is basically just NP, so you're going to say the mean is 58. And now we have to take the square root of 200, which is n times p times q. All right? And so our standard deviation is approximately 6.42. And now we've got all that information, so we have to figure out we have to translate our language here. So we randomly select 200 Americans and ask each if he or she thinks passenger trips to the moon will occur in his or her lifetime. What is the probability that at least 50 will say yes? So we want to know, what about 50? What about 51? What about 52? What about 53? All the way to 200. And so if we're talking binomial, and that's not even do binomial now. If we're talking about binomial, we basically, well, we know the mean's 58, and so we want to know, here's the rectangle for 50, here's the rectangle for 51, 52, all those rectangles, all the way to the rectangle for 200. Those are really what I want to know, because at least 50, so we want 50 and all the rest of the way up. So that's the language for binomial, or with this picture back here, we could say maybe this one here, again, we'll use this one. There's 50, because we know this one here is, the mean is 58. So we'll just use this as an example. I know it'd be a little bit further from the 58, but this is a nice picture, so we'll use that. And so binomial says basically take the area of this one, and that 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 one, and add them all up. Okay? And so that's what it would mean binomial. But what we're talking about as far as normal is we need this one. We need this one. Remember, this is 49's right there. Okay? And so 50's right here. This is right there is 49.5. And so if we're going to look at normal, the normal approximation, we're going to have to use the number of 49.5. That's kind of how it translates. Okay? So we're going to get a z-score then based on that 49.5. So that 49.5 is our x value minus our mean, which is again, 58 divided by standard deviation of 6.42. That z-score is approximately negative 1.32. And it does actually make sense that it's negative, because it is the x value we're looking at, 49.5, is less than our mean. And so it will be left of that distribution there. And so you go and you look up in your tables, negative 1.32, and you find out that the area underneath that is 0.0934. The only problem is what you just found is basically that stuff. And that's not what I want. I want the stuff going that way, right? And so what you do is then do 1 minus that, and it will give you that probability, or the area, for that other one. So 90.66 for that one. So in all the problems, I want you to also find the actual binomial and use your calculator. So this would be binomial CDF. And how many trials are we talking about? 200. And 0.29 is your probability of success. And now here's the tricky part. What number do I want to put in there? Do I want to put 50? Or do I want to put 49? And again, this is the one that some of you struggled on before. Well, I want to basically get rid of all this stuff over on the left. And I want 50 to be included with all the stuff this way. But remember, binomial only adds up from here. And so I only want to add up to that 49th rectangle. I don't want to add the 50th rectangle in there. And so the number, you're actually going to use is 49, because then once I find this answer, I can do the same thing, 1 minus that, and then it will tell me that probability. So let's go ahead and try that on calculator. So again, it's under distribution, right? And it's down a way, so it's probably quicker to go this way. Again, we're getting the exact answer now, and I've obviously gone too far. One more. There we go. Again, that's a binomial cumulative density function or distribution function. And 200, comma, 0.29, comma, and I believe 49 was the one we just set. That's what we would like. And so that's very similar to what we got on the normal approximation. And then 1 minus that, and there it is. So this is 0.9089, we would say. Okay, 0.9089. So this one's 0.9089. So the exact answer is 90.89%. We approximate it to be 90.66%. So I would have to say that that normal distribution is once again, that normal approximation is once again very, very good, very close. Again, if we would have used something other than 49.5, it would have been either too much or too little. For example, if we would have used 50.5, we would have not gotten enough, and if we would have used, say, 49 or 48.5, we would have gotten too much in this case. Okay. So hopefully that made sense, and if there are any questions, I can definitely address those. And hopefully you did good. Example 5, it was reported that 28% of internet users have Yahoo as their browser. You randomly select 125 internet users and ask each whether he or she uses Yahoo as his or her browser. What's the probability that exactly 64 say yes? Now, this is saying exactly 64. Well, that's rather strange. It's definitely different from what we've had. Let's see if we can even use the approximation here. And number of trials, 125. 0.28 is your probability of success, meaning 0.72 is your probability of failure. And so to find out, you do NP and NQ. Once again, NP is the smaller of the two, and so you would probably figure out that one first, and NP is 35, and that makes sense because that's 28% of the 125. And obviously then you can just subtract, and this has to be 90, right? So you know it's going to work. And what that stands for is that the mean here is the 35, and your standard deviation is the square root of 125 times 0.28 times 0.72, and so your standard deviation is approximately 5.02 is what I got. Okay. So now we're saying exactly 64. So all it's asking for in binomial language is that 64th rectangle in the area of that 64th only, not any other ones. And so that gets a little bit more complicated to translate. What that's saying, and our mean was, what again on that one? The mean was 35. Wow. So the mean's 35. Remember, that would be right here is 35. We're way over here at 64 somewhere. So we'll say that's the 64 rectangle right there. That's the only answer I want. and that's binomial speak. But remember, that's a midpoint, all right? And so to find my interval, I have to actually go both ways a half. I have to go to 63.5 all the way to 64.5, which is here and here, to get it to work for the normal approximation. Now, let's face it, our standard deviation is only 5 here, so it's going to take a while. To get from 35 all the way out to 64 is going to take a while. So we're not anticipating this to be a very big answer. At least I hope you don't anticipate it being very big. So let's get our z-score then. Now it's very easy on this one to actually do the z-score wrong. We actually have to find 2 z-scores. We have to find the z-score for 63.5, and we have to find the z-score for 64.5, and we will take the answer of z2 minus the area for z2 minus the area for z1, and we'll find our answer there. But it's very easy to just subtract 64 here, because you want to say 64 is kind of your average, but it's not. Our average is only 35. And so that's why this one's so bizarre, because the mean is so far from your actual value, because your standard deviation takes you a long time to get there. And we're going to divide by 5.02 in both cases. And so this Z1 score gives me a Z-score of 5.68. And this is 5.88. Now, neither one of those are going to be on your table. But where they are is, again, if you're looking at a normal distribution, here's your mean. 5 is way out here somewhere is where those 5s are. And so there's not much underneath either one of them individually. And so then if I start subtracting, there's basically nothing out there. And so we can probably say that the probability of this is approximately 0. It's very, very, very slim that would actually happen. If you had 125 people and you knew that 28% responded to that, and you chose 125 people, it's very slim that 64, which is about half of them, exactly 64 of them would say yes. Half of them would say yes. Very slim chance. And so we'll go and do the other one as well. But this is one you may have messed up on. It's a binomial PDF, not a cumulative distribution function, but just the one, because I only have 64 is the only one I want to know about. And that'd be 125 is how many trials we have. 0.28 is your probability of success, and then 64. So again, this is just going to tell me for 64, so I'm going to add them up all the way to 64. Because let's face it, that would be really, if they were to add it up all the way to 64, that would be almost 100%, almost all 1. But it's not that way. We're only asking for that particular one, so it's very, very minute in this case. And so let's do that. So let's clear these out of here. And it's in a very similar location. But up actually one more. Oop, I hit it. And we got 125. 0.28. Is it 0.28? That's right, isn't it? And we want 64 of them. And so hopefully by doing some more of these, you realize that this is going to be a very small possibility. And what that means, what that E means right here, in this case, is basically times 10. So this is saying 2.4 times 10 to the negative 8th, which means take this thing and move it over 8 times. So incredibly small, 0.7 zeros and a 2. So as kind of interpreted from the other one, very, very close to 0. And so both of them do come out to be relatively close to 0. And so once again, the normal approximation, even though it really couldn't give us much, is fairly accurate, even though it's way out there. But the key behind this one is I wanted to make sure that you knew how to find, when you have 64, well, you need only that rectangle, and so you got to make sure you get both ends of it. Okay, again, if there's any questions, I can definitely address those. Again, the key is to translate, okay, as to what it really means. Translate is kind of this correction for continuity is your translation that you see on the screen here. Okay. Hopefully that went well.